Uh, Welcome to my talk. I'm Binod Pant. I work as a test infrastructure engineer at MathWorks in Natick. I've been there for a few years now. I'm here to talk today about what I'm calling on-demand delivery of browsers for automated testing. With Selenium is the assumption, but the technique I'm going to talk about isn't necessarily tied to Selenium, but it has a great deal to do with testing using Selenium. First of all, I'd like to introduce MathWorks for those of you who are not aware. If you're from how many of you are from the engineering background? Okay. So I take it the rest of you are either from CS or some other fields. If you're from engineering, you probably already know MATLAB and Simulink. So those are the main products, MathWorks. And there's a whole lot of other web products that are also being built or are in the works. And that basically brings up the necessity of having a cross-browser testing tool or set of tools. And that's where MathWorks has been using Selenium. We, the test infrastructure team at MathWorks, have been leveraging Selenium as the cross-browser testing tool for about 2 years now, I think. And we've been testing with all major desktop browsers, including PhantomJS, Chrome, IE, all the major desktop browsers. We used to run with HTML unit. We've deprecated it, but it's still available. We are looking to expand the testing to mobile browsers, embedded browsers, like Chromium Embedded, for example. That's coming up as a popular tool for developers to use to develop actual products, not just for testing, but to build the actual product. So we want to support that mode, and we also want to support mobile browsers, which have their own set of complications with their requirements. But for the purposes of my talk, when I say browser, it's not necessarily just the browser executable, not just the browser, but all of the other requirements associated with testing with a browser. Chrome driver, for example. If it's mobile, the hardware, or the emulators that you need with it for any real sort of testing. So that's what I mean by browser in my talk. We also want this, whatever we provide, to be scalable. We don't want to keep repeating the configuration that users have to do in every of their projects and whatnot. So we wanted this solution to be scalable, cross-browser, obviously, cross-platform, a way for our users, which in our case are the majority of our users are internal users, development teams, quality engineering teams, and the like. So those are our major users. We wanted their life to be easier in terms of handling browsers. Just to show you a couple of samples of products that MathWorks has launched on the web. And there's a whole lot more, but there's a couple here. Cody is a social tool to write, share MATLAB code and solve problems in a collaborative manner. It's on MATLAB Central. Similarly, Trendy is another application that it's a pretty interesting app. I'd recommend looking into it. That lets you draw data from various sources and create plots, charts, comparative charts, whatnot. And lets you keep track of those and share and things like that. It's another social app. These are just examples of applications that MathWorks is building. There's a whole lot more in the pipeline, and the need for cross-browser testing is increasing, if anything. So what problems are we trying to solve with this on-demand delivery of browsers and the requirements? Mainly, like any web-based product or any HTML, JavaScript-based product requires, cross-browser, cross-platform testing, hopefully on a continuous basis, every check-in, hopefully, or every desired frequency. Channel-based browsers like Firefox, Chrome, they update so frequently these days that it's, for development teams and testing teams, it's kind of hard to keep up to date and make sure which browser am I testing against. Am I testing against the latest or not? What are my users using? Just keeping track of that update frequency and making sure you get those updates in what you're testing, especially in a large-scale system, is a challenge if this is not controlled in some form. There are cases, believe it or not, and some of you may relate to this, where you need to support older browsers as opposed to the latest available channel on a build. You might ask, why would anyone use an older browser? One example I can give you, there are corporate clients who do not update at the same rate as normal users. For example, one of your clients may be running Firefox 18 for the foreseeable future. So you don't really have control over that, but what you do have control over is put together a system, say, I want to be able to test with Firefox 18 in that situation. So that's just an example of where you need this flexibility. Similarly, the other side of this, a new browser/platform combination comes along. I don't know, I'm just giving a wild example here, but let's say Firefox OS/Firefox comes along and becomes a need for you to be testing against. How do you add that in a reasonable amount of time to your system without having to do a whole lot of, without having your testing teams or development teams having to do a whole lot of work, where they can just drop in a new line of configuration and boom, they're testing with Firefox OS/Firefox. So that's sort of the place where we're trying to get to, and we believe we are close. We've done a fair amount of work to get to that point. I should, maybe a disclaimer here is, what I'm going to talk about does assume a fair amount about, and this may be a repetition of the slides I'm going to talk about in a few slides, does assume a fair amount of cross-browser testing, CI, so that's not the topic of this slide. All that is assumed to be set up, and browsers are the only additional variable that we're going to deal with. So we just thought of this wild idea saying, okay, what if you could get any browser build, any channel of any browser on demand as you need it based on your configuration for your builds? No additional setup needed. Pretty much nothing to set up except whatever your test infrastructure team has given you as an API to say, ask for a browser, right? So that's the only piece that we want users to have to do in order to request a new browser/OS combination or browser platform combination. Think of it as if you've done parameterized testing in JUnit, conceptually think of it as parameterized testing where browsers are your parameters. So you write a test, run on all desired browsers. Again, some of the same things I've already talked about, the ability to test with the latest version in a given channel. Firefox 21 comes out, you want to be able to test with it now, although that's not always possible, as I'll cover. But you want to be able to test with it as soon as possible, let's say, without too much additional work. Similarly, you want to be able to say, okay, I'm going to keep a build running against Firefox 18 for a while on top of what I'm doing. Whatever we do has to be reproducible. When you send off a script to a buddy, say, here, try and reproduce this. I'm running into an issue. Your buddy runs your test, but if he's running against a different Firefox than you were, there is no reproducibility. So we want that reproducibility aspect as well when you're sharing a whole lot of code around, for example. Similarly, scalability obviously is the goal in any of these types of systems. I'll go through these couple of slides quickly because these are not the main topic. But again, the assumptions I'm making here are build tools, CI, machine farm, the type that Selenium grid deals with, cross-platform testing, and a process to release tools. When I say tool, it's a tool that you may build that builds on top of Selenium, for example, that you provide to your users as an API, as a driver tool or as a page object tool or one of those types of tools that sits on top of Selenium. In other words, you have this dependency on Selenium. You may be waiting for a new release of Selenium to come out to release your new set of tools. So that sort of dependency. So I'm assuming that all this is all set up depending on however your organization has decided to set these up. It doesn't really matter with what I'm going to talk about. Just a brief overview of, on the left is what you see where we were when we started off with the project with our company's infrastructure is you made a check-in, your test suite got scheduled with all supported platforms, and you had that cross-platform assurance. Great. That's the nature of the product drives it. You may not need this for all cases. What we were trying to get to is figure on the right. Windows, great, but what do we want to run on Windows? These browsers. And some of those nodes may be an older release of Firefox, or if Selenium allows it, the other channels in Chromium, for example, not just the stable channel, the beta channel, for example. Maybe you want to run a few set of builds with the beta channel. So all those could be nodes in this figure on the right with what we're trying to get to. So as you can see, the little squiggly brackets, sort of in a set theory notation, I guess. What gets added to your set of requirements on top of, say, OS is something called a browser. So here's my tribute to the retiring Beckham. Once you have the goals and the problems, there are obviously many different ways to solve the problems. What were the possibilities we considered when we started working on this project? Before there was this notion of on-demand, there was no on-demand. We considered, sure, let's build some VMs pre-configured with the browsers of interest, quick, right? Quick meaning, as soon as your VM's up, things are ready, fire off Firefox, done. Great, I mean, this is a great approach if you have, the capability to build infrastructure such as that. Or, it's nice because you can build clean configs without anything else installed on the machine, and it's very clean and nice and scalable. You can check out any VM config you want based on your needs, things like that. Again, some things you might want to, we had to consider when we considered this approach was, in our case at least, and this may or may not be true for everybody, we do not necessarily have full control over the machine farm. We can say, I'm going to have machines running with these particular VMs configured in this way, so I can drop in a new VM whenever I want. So we didn't have that level of control. But if you do have that level of control over the machine farm, it's a great approach to consider. So we sort of passed by this idea. Then we considered, just why not just use external services, Sauce Labs. There's a great tool out there, Browser Stack. Just farm your test out to the external services and don't worry about this. Again, the best approach for when you don't have a pre-existing infrastructure to do cross-browser platform testing, and when you're not going to invest time in building this infrastructure up, you just want to get your tests running, farm it out to Sauce Labs, finished. Basically have most of your requirements met. Some considerations, at least for us, were things like how do we deal with fixtures that have to be available for many of these tests, not just browsers. Some of these tests tend to require more fixtures than just browsers. They could be mock databases, some internal servers that have to be up and running as part of your test cycle, other web servers and whatnot. So coordinating that could become a challenge if you're farming off testing to an external service. Obviously, there are ways around that, but and then there's also the round-trip overhead of running a test, and obviously the cost that you'd pay as you go. So for us, we had a infrastructure, a machine farm of sorts, a Selenium grid of sorts, ready to go. All we had to do was drop in the browsers, and we'd have the other figure that I showed you on the right. So then we consider this other option where we said, why not just drop in browsers as we need? And that's what I mean by on demand. And that brings us to a topic to my topic. Advantages would be you could do this on any machine, right? If you do this right, grab a machine, could be a VM. It's really independent of how your machine farm works, but you get a machine, drop your browser from somewhere, run it. Any browser, any version of any browser, as long as it's available in some store. This can be this could be, in our case, easily fit into a CI system. And again, it's not hard to adopt this approach to work with any CI system. It's really not dependent on that. Obviously, concerns with this: what does it mean to install a browser during time? What if I already have a Firefox installed? What does it do with that? Does it interfere with my local installs? What if I have Chrome installed with auto updates enabled? There's all these questions came up, right? And so we started looking into this a little bit. And obviously, there's the install overhead. If you're installing a browser for every single test or test suite, whatever your unit of testing is, yes, there is that overhead of installing a browser, but you could sort of think that as swap that with the overhead of, say, going out to an external service, or swap that with the overhead of spinning up the VM. So there are pros and cons of each approach. And obviously, if you do this, you have to make sure you do this in a way that makes your machine return to the original state or whatever, or do it in a way that you use temporary directories and clean it up after you're done. So with all these considerations in mind, so with all these considerations in mind, we basically decided to go ahead with this. We had something of a repository technology or knowledge of a repository technology in that we were using Maven for development, and we had familiarity with how the Maven repositories work and how you could put stuff in them and check them out. All right. So there was that we thought about. And then because this was the least resistance path, as I described for us, we decided to go with this. So before we started, what were the types of questions? These came from basically the design documents we put together. Where the browser is going to come from? How are you going to request a particular browser into the build? Do you download it directly from Mozilla Chrome sites? Doesn't sound like a particularly smart idea, especially if you have hundreds, potentially thousands of test machines requesting browsers. You don't want to generate that churn. Plus, in our case, we could not assume the test machines had internet access even. So there was that issue. This meant we needed something internal, like an internal storehouse that could give you a browser on demand. So we took that into consideration. And all the other questions about whether we will interfere with local systems. Now, when I say interfere with local systems, it's not really a consideration for test machines running in automation, which in most automation systems, they are started up clean, and you're given a clean machine to run on. There's nothing additional installed. So you can do your thing, let go of the machine, it gets cleaned up, or if it's a VM, it gets discarded. So that obviously is going to have to be there for clean tests to be running. So we didn't worry too much about that. Okay, how are we going to manage that? For developer machines, it's a different story. You have a developer machine where you're running. We want the same set of tools to run in automation and locally. For example, if you're using Ant, you should be able to do Ant install or whatever locally, and the equivalent command is running in CI. So we want the same workflow to happen. And for developer machines, we had to do a few things to make sure we don't interfere with local browsers. But that was not an issue for automation. So how did we go get started with this? First of all, we figured out a way to store browsers in a repository because we needed this, as I described. How many of you are familiar with Maven and Maven repositories? Okay, so about half of the folks here. Basically, a Maven repository is a storehouse. It's an HTTP-based server or whatever-based server that hands you out resources when you ask for it. That's the technology behind Maven. And when you add a dependency to your build, it locates an artifact in the repository based on your coordinates and downloads them for you. Right? So that technology is a known technology. It's nothing new. Well, we said that why don't we extend this to browsers? Say you have a browser that's stored in the repository with a set of coordinates, and when you run a build with Firefox release channel on Windows, for example, if that's your requirement, then we'll locate that browser for you in the repository with the group ID, artifact ID, and the version classifier. These are for people familiar with Maven, these are nothing new. This is how you specify a dependency. So we said, let's give each of the browsers in the system these coordinates. So the example down there is an example of how we would store the release channel of Firefox, build number 18 for Windows, in a section of the repository that we call release on the left over here, but I'll talk about that, the section of the repository's idea. But let's think of it as a repository with a few sections, and there's browsers in these buckets, right? And the release bucket is the one where the users are actually going to get browsers from for normal testing cycles. There's other buckets. So once we set this up, we set up a Nexus repository, separate repository just for browsers. And adding a browser to the system was fairly easy. You go to the Mozilla site or grab the URL for the right browser you want, download it, zip it up, do some things with it if you need to, and deploy it using standard Maven commands. There was nothing too fancy about this, although we did automate a whole lot of this with shell scripts, so I wish I had a demo here, but basically adding a new Firefox release to the system is a couple of minutes, plus obviously the download time. So I fire off a shell, say download Firefox 18, deploy Firefox, done. So it's as easy as that to add a browser to the system. So so that addresses the issue of storing the browsers. How do you actually ask for those browsers? We didn't want users to have to add a whole lot of configuration, on top of what they're already doing, or dependencies to their projects. And again, we're going to need to support Maven users, Ant users, Ruby users, maybe, who knows, right? There's all kinds of users using Selenium to run tests. And I'm sorry, I haven't actually tied this to Selenium yet, but that's coming in a bit. So we wrote a piece of central library code that sit on top of Maven 2 API, and I'm hoping we can go to Maven 3 at some point. But basically, it sits on top of Maven 2 API and knows how to request these browsers given the coordinates, right? How are the coordinates formed? If you look at this example, which is a Maven example, and I'm sorry for if you're not familiar with Maven, again, I tried to make it as simple as possible. We provide a plugin, which is sort of the standard way in Maven to get a new functionality into your build without actually affecting what you're releasing as a part of the life cycle. We provided a plugin that would say, it's a browser plugin, right? You add it to your POM, and you ask for the release channel of Firefox in that way, and the stable channel of Chrome. What that's going to get translated to is those coordinates that I talked about in Maven to a specific number, to a specific version of Firefox or Chrome in the repository. And the way that usually happens, again, there's various models I'll talk about, is you get the latest available build in that channel. So if Firefox 21 has come out and we've managed to qualify and push it into the repository, then you get Firefox 21. So in a way, you could think of it as automatic updates or whatever, maybe not automatic, but yeah, updates for your builds for browsers. So once you add this in, you're done. I mean, you never touch this config again unless you want to remove Firefox from your build. and you do it once. For Ant users, same idea. We provided a task. They provide these as configs, and they're done. For some custom infrastructure we had, we did the same thing. In other words, once we wrote the library code, the central library code, it could be used pretty much anywhere. There was no assumption about the type of tool you're using. So that's that. A little bit of an overview about how exactly the browser API works, how exactly the downloading works. It starts over here with the blue box here with that plugin that I showed. That's your build. That's your Ant file, whatever that is. Selenium, Ruby file, whatever that is. You add the browsers to your list when you run it. When you run your build, the Maven plugin in this case requests the browser API. What is the latest available number for Firefox release? It goes to the repository, gets you the latest version or whatever the version is based on the strategy you're using. Once you have the number, it's a matter of using the Maven API to download the browser. One advantage of doing that, of using the Maven API, we found out, again, this wasn't by design or intentional initially, but you get that local repository behavior, which could be termed, thought of as caching for browsers for free. Meaning, on a developer machine, if you run your build twice with this setup, the first time you'll see a download happening, you'll see Firefox 18 being fetched into your system. Second time you run it, you never download it again as long as you have a local Maven repository. So we get that behavior for free. It was sort of a pleasant surprise when we did this. So second time you run, your build is much faster. You don't see any downloads happening for the browsers. So what actually happens? The browser is downloaded. It's extracted into a temporary location, like I've shown over there. Any additional setup that needs to be done is done. When I say setup for Firefox, there is no additional setup as of now, unless Marionette comes online and we have to do something there. But for Chrome, for example, we have to also grab the driver, Chrome driver file. That is also, by the way, versioned in the system and configuration managed. If it's Phantom.js, we also have to grab the right executable for that platform. So it does so the browser library code is capable of doing all of that for every type of browser. Once it does that, now it's a matter of using the standard Selenium capabilities API to say, here's the browser binary, go use it. Once you have the browser, Selenium is fully capable of using any browser you have. And then from there on, your tests now become enabled to use these browsers. As you can see, this can easily extend. You could have 6 of those browser tags in your BOM, and you get testing with 6 browsers, depending on what you wanted. And then there's the cleanup step, which if you're using a temporary directory, it's a simple delete. And then just a sampling on the right of how the log looks. It'll tell you exactly which browser version your test is running against, and it'll tell you that it's getting the browser for you. So this is what happens during installation. Just a brief mention of what we had to do for the various browsers. Firefox was the easiest. You just unzip and go. There's no strings attached on all platforms. Chrome was the same on Mac and Linux, and it works sort of out of the box. You unzip it, no interference. You can have another Chrome running, and Selenium does a great job of keeping the isolation there. Chrome on Windows wasn't exactly easy, and this is something, if Google folks around, we can probably chat about it. Chrome on Windows, as far as we could tell, required an installer to be used. So we had to also publish the installer, the standalone installer for Chrome that you see on the internet, not the regular installer, along with whatever Chrome binaries we pushed in. So we had to, for Chrome Windows, we actually had to push in two artifacts. One is the unzippable Chrome that we would drop in side by side with your normal Chrome install. So if you had Chrome 21, we could drop in Chrome 23 and have it running instead of 21. So that we needed to deploy. And then for cases where there's no Chrome installed on the machine at all, you're running on a clean machine like in automation, we figured we had to use the installer executable to install Chrome. We just fire off the installer, let it do the install, and then uninstall in the end. So all that would happen as part of this. Phantom.js was relatively easy with the driver executable, IE driver, same thing. So that was what was involved in actually creating the deployment/installation code. There were a few edge cases we had to work around, like IE8, IE9. There's no installation, right? You have to have a machine where this is installed. Safari 6, same thing. And there's the question of interactive use. How do I grab these browsers and keep running my tests in my IDE without having to go through that step all over again? So we address all of those by providing switches, a few switches and flags that you could set in your run configurations so that you could keep the browsers around, keep running your test for development, submit it, and CI, the whole thing would take place. So once we got this working, we weren't exactly done in the sense that in real life, you never, at least when you're depending on Selenium, depending on a tool that depends on Selenium, that depends on or has to work with all these browsers, there is that lag time between when you can actually start testing with full fidelity with the new release of a browser. And we experienced that firsthand when we started doing. We couldn't just push out a new browser and have it be available to everybody instantly in the organization. We had to set up a qualification process of sorts. In real life, if you get a new browser update, you wait for a new Selenium release most of the time, although that's improving. And you release your new tool that depends on Selenium, let your users know or whatever, and then either they update to the latest version of your tools and get the latest browsers, or you set up a system to get the updates in automatically. So one of those things needs to happen. So I talked about the stages of the repository. To control this, we basically divided the repository into stages where we could push a new browser into the staging very quickly with the thing that I talked about, have a preview step once we've qualified our tools with that browser, and let people start using those browsers that new browser in preview mode. And then once we're done, release. What happens after that depends on one of these two models that I'm going to briefly touch upon. Looks like I'm running out of time, but there's two different ways we've done this. If you go through the diagram at your leisure, I guess. The last step is the one I want you to look at, the push browser X to release and the browser update arrives on channel. What happens after we push a browser to the release section of the repository is dependent on how you set up your model. We could say when we push a browser, everybody is on the new browser automatically. There's nothing to do. That works great, except there are scenarios where your users may not be ready for the browser updates. They may need that preview time. They may need more control over the producibility over which browser am I getting when I use your tools version X, of the sorts. So to produce that, to provide that level of compatibility, we also developed a second model, and both are in use. What you use depends really upon your organization and your mechanics, but the tooling doesn't really assume either one. It's capable of doing both. CI builds running in production mode, whatever that means, may want to use the lockdown, the second model over here. And if you have developer builds that really want to be on the edge, you may want to use the previous model where you get browser builds as soon as it's pushed. So the results of this have been great for us. We've been using this system for over a year now. We get for every check-in, we get cross-platform times, cross-browser testing, and we can add a new one. Like adding Phantom.js was a one-day effort, less than a one-day effort with this. Those are the easier cases. The more difficult cases take a little bit more time, but it can be done, and it keeps all this complexity out of the user's configuration. So that's basically the end of my presentation. If you have any questions.
Your audience for using this system, is it mostly specific test people, or is it development, or both?
It is actually both. So that's a really good question. One of the major use cases for this obviously is CI, right? When you're running builds in CI, what happens? You get these browsers and get, for local qualification, as I mentioned, we couldn't have this happen every single time you run a Maven install, for example, right? Or we had to do this in a way that it's cached and it's faster the second time around. So that was there. But in addition to that, we also listened to our users who were asking for, what if I fire off my IDE, you want to keep hitting the run button without having to do anything else? You install the browsers once using something like pre-integration test in Maven, and then you just keep hitting your run button, and you get testing with that browser that's been installed by the tool. And then we also provide for users who said, okay, all this is great, but what if I want to test with the browser that's installed on my system, for a quicker turnaround preview the new browser. We also provided a switch. You could -D or provide an environment variable that would switch you to local browser mode, after which you could specify your local browsers in a list, and it would use that instead. And we had JUnit runners in our case that would loop over the browsers and give you a test instance per browser. So that's how it worked. Any other questions? Okay, thank you.